Welcome back to The Doctor Is In. This week we're continuing our new series, What Plants Crave from Technology, and we're also continuing our interview from last week with Dan Dettmers of Quest Climate. As always, thank you for growing with us.
So that was a great segue because, and you brought up desiccant earlier briefly, but why is desiccant not more prevalent? You mentioned earlier it's not very efficient. What does that mean? And, I guess why don't we see desiccant in normal operations, but you would, I think we would both recommend it at these really low dew point conditions. Why?
Sure. The biggest is the efficiency of the unit. So I like to hearken it, and since I actually take care of our desiccant line as well, I spend a lot of time comparing. And refrigerant dehumidifiers are kind of like the sports cars of the dehumidifier world, whereas desiccants are the Mack trucks, right? So your refrigerant dehumidifier, as temperature and conditions as that dew point goes up, as the dew point comes down, as the temperature and relative humidity goes up and goes down, so does the capacity and so does the efficiency. So, for example, our Quest 335 that we just came out with about a year ago, at 80 degrees, 60% relative humidity, I mean, we're talking about 9.3 pints per kilowatt hour, meaning you're getting 9.3 pints for every kilowatt hour of electricity. You drop that down to 70, 50%, now you're down to about 6.9 pints per kilowatt hour. You drop that all the way down to 70, 40 or something less, you're going to be down in the range of 2 to 3 pints per kilowatt hour. Now, compare that to a desiccant. At 80, 60, a desiccant's going to be doing about 1.6 pints per kilowatt hour. At a dew point of minus 20, it's going to be doing about 1.2. There's not a lot of change. It doesn't get any better, but it doesn't get much worse. It just keeps trucking along, doing its job, which is great, but it's doing its job really inefficiently. So when you're looking at a desiccant, it's going to cost more to purchase the unit per pint of capacity. It's going to cost more to install it because there's a lot more ductwork that needs to be installed, and most of them are going to be 460 volt 3-phase instead of 220. And then it's going to cost more in the long run to operate. So whenever somebody comes to me and says, I want a desiccant dehumidifier, I stop them. I say, why? Let's talk this through. Why do you really, really need one? And if they convince me they really, really need one, then we'll talk about selling them one. But you got to convince me that you've got some reason that you need to be at really low temperature or really low relative humidity. Or I have run into it a couple times where someone had a really unique design where they needed low dew point air, and it actually did save energy. Very unique designs, I'll put it that way.
What makes them so inefficient?
It's the process. So the whole process of the way a desiccant works is air goes through the silica gel, and it's the same stuff that you buy shoes, you buy electronics. There's that little packet that does desiccant, do not eat. Well, that's a water scavenger. It grabs any water that comes into that package and holds onto it. Well, eventually it becomes full. So the only way to regenerate it, to push the water out, is to throw it in the oven and bake it, right? Well, that's not very effective. I don't know many leafy green operators that would want to fill their room full of desiccant packets and then take them home every night and throw them in the oven, right? Not going to work. So instead, what we do is we put it on a honeycombed wheel, and we bring air from the space. It goes through this honeycomb wheel that this desiccant sprayed on. The desiccant sucks up the water. Now, in the process, it's an exothermic process, so it does give off a little bit of heat. Not typically as much as you'll get off of a standalone dehumidifier, but still some heat. And now that warm, dry air goes to the space. But as that desiccant gets saturated, we put it on a wheel because that wheel's slowly turning, and it turns into a second airstream. The way we regenerate it is we take air from outside, air from the hallway, air from someplace else, bring it in the unit and heat it up to about anywhere from 200 to 280 degrees Fahrenheit. Push that through the wheel, that dries the wheel out, and then we take that warm, humid air and we throw it away. Well, now that's heat that we're not recovering to reheat our space at night. That's a lot of energy we're using in order to dry that wheel out. That's why it's such an energy hog, because just fundamental way of how it works.
And there's no way, I mean, we're dumping out this warm, humid air off of the desiccant to dry it. I've heard people ask this question. Of course, like the next question, well, I don't know, if, of course, but like one of the first questions that I think of is, we're also losing the opportunity to potentially collect the condensate, right,
Mhm.
from that dehumidification process. But then you think, oh, well, let's collect it and then let's run it across a cooling coil and condense the water out. And what did we just do?
Right. Now you're using energy on top of energy on top of energy. I remember when I was about 25 and first started out in the HVAC industry, and that was the way I thought. It was like I kept going to my boss going, can't we recover this energy? Can't we recover that energy? And he's like, you can always recover energy. It's just what's it going to cost you to do it? And so that's what it comes down to that desiccant is, yeah, there's ways we can recover some of the energy, but it just becomes inefficient, too costly in order to recover that energy.
Yeah. How have you seen dehumidification technology change over the years? Has it changed much?
Well, from the standpoint of the refrigerant dehumidifiers, it's still fundamentally you got to get a coil cold, run the air over it, and then get rid of the heat someplace. Where it's changed is there's various ways of doing it that improves the efficiency. If you look at, and I'm hoping your audience kind of has a little bit of knowledge of our product line. If you look at the Quest dual units, the 225, for example, is the most popular one. If you open that thing up, you're going to see this big flat black plastic heat exchanger. And what that is basically doing is it's pre-cooling the air coming into the unit. So when that air hits the evaporator, it's already cold enough that the evaporator can do as much possible moisture removal without having to cool the air down to the saturation point. And then we kind of recover the energy. So it loops around inside, and now the cold air coming off the evaporator is what we use to pre-cool the air coming in. Others use something called a heat pipe, which is basically a couple of coils filled with refrigerant that just using natural fluid motion will move heat from one side of the coil to the other. So in doing so, basically, again, pre-cool the air coming to the evaporator. So that way the evaporator is focusing more of its energy on pulling water out rather than cooling the air. If you move to our Quest multi-coil units, or our M-Core is what we're calling it now. I should back up. This is how focused Quest is on our marketing. We've had this patent on this multi-coil design for 6 years now. And I think this is the year that we finally went, we should probably name it something. So we finally came up with a title of M-Core, multi-coil refrigerant recovery process, to describe basically the same thing as the heat pipe, except for it's all part of the same loop. So we're using the refrigerant 2 or 3 times in order to get both an efficiency and a capacity boost. And that's the biggest revolution that's come about in dehumidifier technology pretty much since Willis Carrier figured out that taking air and cooling it down pulls moisture out. Because the backstory there is Willis Carrier was trying to invent a dehumidifier, and he accidentally invented an air conditioner by mistake.
Yeah.
And that's how this industry got started.
Yep. It all started with dehumidification, which I actually, one of my podcasts earlier this year, I talk about HVAC, kind of some of the basics and the history of HVAC, including Carrier's story, for anyone who wants to listen back on that. I like this idea of preconditioning the air and then, with a low source of energy before running it across the higher, more energy intensive evaporator coil to do the dehumidification. I feel like when we're designing air handling units, using chilled water, I feel like there's more flexibility and opportunity to build in some of those energy efficiency strategies. But with package systems, it kind of surprises me that I don't see it more. Some of this creativity to have a pre-coil and then a post-coil type of thing. And we see it with wheels, and we see it with some heat exchangers, right? That might precondition some of the air, but sometimes those are still secondary systems and they're not built into the package. Is that an area where, dehumidifier manufacturers could advance the efficiency of this technology, do you think?
Yeah, so a lot of it comes down to, as a manufacturer of HVAC equipment, whether you're talking dehumidifiers, air conditioners, package units, large chilled water systems, is there the market there for you to provide that many nuanced differences, right? So with Quest, right, our dehumidifiers, they don't just go to the CEA world. I hate to admit it, but the same unit that we sell to a leafy green grower is the same unit that we're selling to someone with a swimming pool or an office building, because there's only so much changes you can do. Now, I mean, I'll admit that the CEA world is our primary target, so we design it for that one, but we still look to the other ones for additional sales. Same thing with air conditioning equipment. So when you're building these rooftop units, they're churning out tens of thousands of these. Same thing with split systems. There's only so much you can do to make changes to the fundamental design without adding significant cost. And it makes sense in the beginning when you're sitting down, with a fresh blueprint in front of you, and you're saying, hey, I want to design the ultimate facility, and I'll spend a little extra to get what I want for HVAC, and I'll spend a little extra to get the proper lighting, and spend a little extra for this and for that. But man, having had a farm myself, at the end of the day, you get down to the counting the last few nickels, and you're like, okay, do I go with the advanced lighting, or do I get a beer fridge for the break room? Boy, it's a tough call to make, right?
Yeah.
Your budget's only what your budget can handle. And so the manufacturers realize that. So, something like a packaged rooftop unit, it's going to be designed to handle all these different applications, and there isn't the opportunity for resetting the suction temperature, resetting the evaporator temperature, as we put it, versus chilled water. Okay, now when I have a chilled water system with a great big chiller, those are designed to change water temperature all the time. So you can take them up to 50, 60 degrees. You can drop them down to 40, 35. If you put some glycol in it, you can go well below 32. So now you have a lot more control in order to get the evaporator temperature, the coil temperature you want, to get the dehumidification you want, to get all the system you want. But now you have a very expensive and very complicated system where you might have to hire a specific person with a background in HVAC and facility management in order to operate it for you.
Yeah.
Hence why the chilled water systems that you're seeing in an industry, I mean, those are going to the really, really, really big facilities. It's just not a feasible one for, your typical craft grower or even mid-sized grower.
Yeah. The grower who wants to be more focused on the plants and not be a facilities engineer themselves.
Exactly.
Though growers end up wearing all those hats anyway, right? They end up being they end up being the plumber, the electrician, the HVAC engineer, right? Their own contractor.
Back on my farm, we had a greenhouse. I took care of the HVAC, obviously. I also was allowed to occasionally water the plants only when they needed me to, right? But yeah, we all had to wear many, many different plants. I was mostly the janitor. I came in and cleaned up everything because that's all they trusted me with. Nobody trusted me with shears to do pruning or anything like that, or propagation.
That's what I've heard about brewing as well, is that you're basically a plumber and a janitor.
Oh yeah. That's it's one of the biggest breweries here in Wisconsin. He doesn't go to other breweries to hire his help. He goes to the cheese making plants because cheesemakers know all about sanitation. So he hires former sanitation workers from the cheesemakers because that's most of brewing, is making sure that you don't have anything left over from the last batch to infect the next batch.
Interesting. Yeah, that makes perfect sense. While we kind of started veering towards efficiency a little bit.
Oh, I thought you were going to say, well, we're drifting way off course.
No, we're not.
Okay.
I don't think.
We're going to veer back. For those of you listening, this is a typical conversation between Nadia and I.
Yeah, it is.
It starts in left field, veers all the way over to right field, ends up in the parking lot, and then somehow back behind home plate.
Back in the stadium, exactly.
We're all over the stadium.
So, speaking of efficiency, I'm going to start with the first question, which is, why is dehumidification so energy intensive?
Because. Is that enough?
Fill in the blanks, people.
So why is dehumidification so expensive? Partially because in the CEA world, it's again one of the few applications where you actually have to think about dehumidification, where you actually have to do intensive dehumidification. When you're talking about a school or an office building, dehumidification is just a byproduct of the air conditioner. You're paying for that temperature reduction. The fact that you get dehumidification, hey, that's great, but I wasn't even thinking about that. Whereas now when you move into the plant world, you actually are thinking about how much dehumidification you need, and you're thinking about what's this going to cost me. And now when you start getting into the technology, hey, air conditioning, we're paying again to cool that air down, and that's it. Now with dehumidification, we're cooling the air down and warming it back up because we don't want to blow 55-degree air on our plants, and we don't want to cool that whole room down to 55 degrees.
Or 47-degree air.
Or yeah. 45 or 40. Or, yeah, keep going. So yeah, so the dehumidification, is it expensive? It's as or a little bit more expensive than your typical air conditioning, but again, it's a necessary process that we don't normally think of.
Over time, do you feel like people have less sticker shock when you quote a project for dehumidifiers than they did maybe 3 or 4 years ago?
Oh, first time growers, whenever a state goes legal for the first time and they start calling up and you say, okay, here's the dehumidifiers you need, and they go and get the pricing, it's always like, oh my gosh, because when they think of dehumidifiers, they think of that thing with a bucket that you buy from Walmart for $200.
Yeah.
I have heard of people filling up their grow operations. I don't know if they run around and empty the bucket every half hour or how that works. But with those units, the efficiency is so low that you're going to pay for it at the electric meter. And the amount of heat that they put off is so high because the heat is not just from the water removed, it's from the inefficiency of the unit. The less efficient the unit, the more heat it's going to put into the space. Now, as time has gone by, once people understand what systems cost, people have come to expect it and budget it out, and it's worked in as part of the total price of the HVAC and D package.
Yeah.
There's your new terminology, and one that California is pushing, HVAC and D for dehumidification. And
I'm pushing against it.
Oh yeah, I applaud that. Hey, thank you. Thank you for acknowledging the redheaded stepchild of the HVAC world, dehumidification.
Yeah, exactly. We just talked about how dehumidification has always been part of the equation. It's always been like that was the beginning, right? Now all of a sudden, 120 years later, we're going to add the D to the acronym. I don't know.
Finally.
Finally, it gets its due. I would say for me, early in the days of Dr. Greenhouse, I would be talking to growers that would budget 5 or 10% of their CapEx on HVAC. And, I would just basically ask them, well, what are you trying to control exactly with that HVAC system? You know me, of course, I'm going to ask that question like straight out,
right.
like, and I would say that now what I tell growers, especially after an accumulation, right, of experience, is you're looking at probably around 30% of your budget being on HVAC. It can range, right, 25 to 35%. Yep. But also, as LED light prices are coming down, it seems like at the same time HVAC prices are going up. And so I kind of wonder how long my 30% rule of thumb is going to be true.
Well, yeah. And as LED becomes incorporated, it's less heat in the space, so it means less air conditioning. So
Yeah.
theoretically,
Yeah,
you
there
should
you
be
go.
saving.
Yeah.
But
Maybe they come down together.
I hope a lot of that, depending upon material pricing, because
For sure.
we are slave to the price of copper, aluminum, and steel, big time.
Yeah. Have you, just to bring it up, have you guys had to deal with a lot of the supply chain issues other manufacturers are?
Yes. Especially through the pandemic, we had whole teams of people that were constantly trying to negotiate with our suppliers to make sure that parts were arriving on time. Because there was huge shortages, and we did hit some pretty significant lead times. But through it, I have to give kudos to our supply team. They even went to the point of hiring people in Southeast Asia and Europe, other places, so they had boots on the ground there to show up at the factories and say, hey, where's our valves, where's our evaporator coils, where's everything that we need. As much as we could, we moved stuff in house, but there's only so much you can do. It's been a real challenge. I think we see the light at the end of the tunnel. Like, things are starting to straighten out, where supply chains are starting to get back to normal, but there's always some new hiccup that pops up.
Right. Why, to segue towards the conversation around energy and the energy code and the work that you've been involved with as a stakeholder in the industry. Thank you very much. I want to start with the question of, why does dehumidification require so much energy compared to, say, just regular air conditioning?
Sure. Dehumidification. So air conditioning is the process of simply cooling the air down. And when we cool the air down, we take out the heat, we take out some water, and that's the end of the process. With dehumidification, we're cooling the air down and then we're heating it back up. So now the cost lies in, well, more infrastructure within the equipment, more energy consumption, depending upon where that heat's coming from. But
does it take more energy to also produce those colder refrigerant temperatures as well?
It does, because your compressor, think of your compressor is the unit that takes it from your refrigerant from low pressure and moves it to a high pressure. Well, the lower the temperature you need to go to, the lower pressure you need to go to, so the harder your compressor has to suck, right? I hate to use that term, but it's pulling from a lower pressure to try to discharge. So it's got to work a lot harder and use more electricity than an air conditioner doing, in the same space, because it's pulling down from that lower temperature. And then on the other end of the equation, depending upon where you get your heat for reheating, hopefully you're using recovered from the system, but you might be paying for electric or gas consumption in order to heat it back up.
That makes perfect sense to me. So tell me, you mentioned earlier California's energy code, 75% heat recovery. What are some of the other energy code requirements around dehumidification and HVAC specifically with the new energy code?
So, good question. What's coming on in California? The interesting thing is, prior to Title 24, this controlled environmental horticulture requirements, there really was no efficiency requirements for standalone dehumidifiers at all. The only stuff you could find was Department of Energy has requirements for residential dehumidifiers, whether it's the little bucket one you get at a Walmart or a Home Depot, or the residential kind that you might have as a whole home. Still all pretty small stuff. They have energy efficiency requirements that are based upon basically their applications. So they break them into whole home and portable. A whole home dehumidifier means it's set up with ductwork bringing air to it, ductwork taking it back, and based on the case size, the size of the box, right, that the dehumidifier is in, if it's less than 8 cubic feet, they have to meet 3.74 pints per kilowatt hour or better. If it's bigger, if it's 8 cubic feet or larger, which is the size most of our dehumidifiers in the controlled environmental horticulture industry are, they now have to meet 5.1 pints per kilowatt hour. So that's requirements for the little ones. Then there's a second classification called portable. So portable in your home would be a dehumidifier in your basement or in the crawl space underneath. cold, damp areas. So they're going to be rated at a much lower condition of 65 degrees, 60%, not 73, 60. But it's also defined as a unit set up without any ductwork. And they also have to meet a much higher efficiency level of 5.9 pints per kilowatt hour. So that's a pretty tough number to meet.
That's a lot higher. I mean,
it's significantly, and it's
and
very hard for most manufacturers to meet.
Yeah. Why? Wow. Why did they do that? Why did they set it to be a higher efficiency at such a lower temperature condition?
Well, that's a question we have asked the Department of Energy many times over the last 5 years, and we never really got an answer. But those rules are being revised right now, so we'll see what comes out in another year or two when that whole process is done.
Okay. Well, I mean, the good news is that those portable dehumidifiers, not that we would ever necessarily specify portable dehumidifiers for a drying room, but those are conditions that we frequently see, right? 65, 60 for a drying room.
65, 60 is a number that we see in drying rooms all the time.
Yeah.
So there you know that your unit's going to be efficient. But for better or worse, all those definitions and conditions have now been transported over into California Title 24. So when you start looking as of January 1, 2023, if you're going to hang a dehumidifier in the space without any ductwork, that unit needs to meet that 5.9 pints per kilowatt hour at 65 degrees, 60%. Make sure that that unit meets that compliance, or your building code official might have a problem granting you an occupancy permit.
Even your larger 8 cubic feet one?
Oh, on the portable conditions, it doesn't care what the size of the unit is. Okay. It's only based on the capacity unit, which is 50 pints per day or greater, which pretty much all of our dehumidifiers we use in CEA are going to, I'm sorry, California, CEH, they're pretty much all going to be 50 pints or more.
But you're saying if they ducted it, it would require a lower efficiency?
Correct. Does this make sense?
No.
Exactly.
Okay, but
I'm sorry. If the unit is ducted, then it would be considered under federal regulation a whole home installation. So therefore, for a unit with a case size greater than 8 cubic feet, which again is most of the units, now they only have to hit 5 pints per kilowatt hour at a much warmer condition of 73 degrees, 60%.
How ducted does it have to be?
I don't know. That's between you and your building code official to determine. I will tell you, the regulation just says that it has to have ductwork returning air to the unit and ductwork supplying. I guess if that ductwork's only 3 feet long and your building code official's okay with that, then that's between you and them. I am definitely not making interpretation of California regulation.
Okay, but I'm still confused though, because where does 80/60 come in?
Nowhere anymore.
But that's the rated condition, right?
So technically, 80/60 hasn't been the rated condition for, I think it's been 4 or 5 years now. 80/60 was a number that was used way back, established by an organization called AHAM, American Home Appliance Manufacturers Association, or no, I'm sorry, Association of Home Appliance Manufacturers. That's it. They established 80/60 as the test conditions because that was the conditions you saw in a swimming pool. And so that became the rating conditions for dehumidifiers because that's where dehumidifiers were used back in the time. It made sense back then. I mean, we'll still publish numbers at 80/60 because it's what everybody's used to seeing. But I mean, how many grow operations are 60? I mean, I guess a few leafy green ones, but not too many cannabis or other vegetables.
Right. And that's usually a big point that I make, is that, not many growers are operating or targeting 80/60, but that also, I mean, why still publish the performance data at those old testing standards if, one, they don't apply to the energy efficiency ratings or requirements, and we have this other testing standard that is more close to indoor grow environments?
So at least at Quest, we're trying to push the industry forward. So you'll see all of our spec sheets coming out soon with It'll be 80, 60. You also see 75, 55%, I believe. You'll also see its efficiency and whatnot at those rating conditions to show compliance. And by all means, you can ask us at any point, hey, Dan, we want to run our grow operation at 73 degrees, 44%. I'll get you the performance data for that unit at those conditions. More than happy to. The problem is not everybody's playing with a level playing field. We often see less than reputable manufacturers coming out and saying, here's our 200 pint per day unit, but that's at 80 degrees, 80% or 90%, right? At conditions you would really never see. And of course, the unit can get 200 pints per day at 80 degrees, 90%. But when it drops back to something that you actually need it, like 70 degrees, 50%, now it has almost no capacity left at all. You want to make sure you read the fine print. And if you don't see your rating conditions, ask the manufacturer, whether it's a standalone dehumidifier or any other technology, how much capacity am I going to get out of it at these conditions and what's its efficiency? Because I need to make sure, at least in California and Vermont and Washington and soon to be New York, that I meet the minimum energy efficiency requirements of all those states. So I need those numbers to verify that.
And I'll say that I've always appreciated your transparency and openness to share those performance data with us when we have a specific, our temperature humidity targets are off in left field, and we're like, okay, we don't want to oversize this system because we don't know what the performance is going to be. So thank you for that. I'll
confess, Nadia, I didn't know I ever had the choice when you asked me.
Well, you didn't. I mean,
okay.
But I mean, I will say, in your comment here that it's good to know, you're not just favoring me. I mean, you're going to share that information with everybody. So I guess everybody.
I'm happy to share it with everyone. I'm forced to share it with Dr. Greenhouse.
So if you don't hear back from Dan, you can always contact us.
Right.
But so our integrated HVAC systems don't have that same requirement, right?
Nope. So what's in there right now in California Title 24 is there is efficiency minimum requirements for cooling systems. There's minimum efficiency requirements for standalone dehumidifiers. For integrated HVAC systems and chilled water systems, there's simply the requirement that for the reheat energy, 75% of it comes from on-site generation, recovered energy from on-site or solar energy generation. And then the final requirement is desiccant systems can only be put in if a dew point of 50 degrees or less is specified. So they did make the allowance for putting in desiccants. It's just basically highly discouraged.
Right. You really have to need it. Basically. Yeah. Because to your point, it's very energy intensive. What else about energy and dehumidifiers? Anything or not even energy, but what about moisture removal efficiency? I hear that term.
That's another terminology for the moisture removal efficiency. Kind of comes out of the swimming pool dehumidifier and dedicated outdoor air systems, but it's essentially the same thing. How much water do I get out for how much energy, electrical energy or other energy I consume to get that out?
Which sounds exactly like liters per kilowatt hour. I mean, that is the MRE, right?
Correct.
Okay. So in those cases, then for those, say, pool dehumidifiers, there's less of an emphasis then on EER, on energy efficiency ratio, and more on the moisture removal efficiency.
Yeah, they'll be rated on both, but more of the focus is on how much energy is being consumed to pull the water out versus pulling the heat out of the air.
Okay. What do HVAC engineers, what do they not understand about CEA that you wish that they did?
Or
that would just help
where
the
do
industry.
I start?
I know. Again, another conversation that we can have over beers and cheese at Ashtray, right?
Right. I mean, we can start with they don't understand that plants are living biological entities that change all the time. I mean, that's a really good place to start. But fundamentally, what they may understand but don't grasp is the latent loads involved, right? And how equipment responds to it. So the biggest mistake I see with engineers that could come from the HVAC world and are maybe on their first or second CEA job is they don't completely grasp the moisture removal capacity of the air conditioning equipment, right? When they're designing, again, I mean, I've hit this before. When they're designing a school or an office building, they pick the air conditioner based on how much heat they need to remove to get the temperature they want. And the moisture load just kind of comes along for the ride. And it's usually taken care of because it's assumed, and that equipment's designed to take about 15% of the total load is going to be latent, and 85% is going to be that sensible, that heat. Well, when you get into a grow operation, especially late in life, all of a sudden, the latent load is now 30, 40, almost 50% of the total load. And now that equipment just chokes. It can't handle that latent load. It doesn't know what to do with it. So they put in this equipment and it's woefully undersized for the latent capacity. So what do? They buy a bunch of standalone dehumidifiers and put them in. All right, that takes care of the latent load, but now those dehumidifiers are putting some heat into the space, and they're no longer sized on the air conditioning side to take that heat care of that heat. And so they end up having to come back and retrofit additional air conditioning capacity. So in their world, they talk about the phrase is sensible heat ratio. So that's the ratio of sensible heat to total heat. And they're always thinking of sensible heat ratios around 0.85 to 0.9, meaning 85 to 90% is heat and only 15 to 10% is latent. Whereas in a grow operation, now it's more sensible heat ratios of 0.65, 0.7. And that's where you need to really talk to the manufacturer and say, are you taking that into account in this equipment that you're selling me? Talk to the engineer. Are you taking that into account in the system that you're designing for me? Is there going to be enough capacity to take that latent out? That's the biggest hurdle that most engineers have when they first come into this industry.
I agree with you 100%. What about the dynamics of the grow room in general? Was that something that you also were challenged with in the beginning? Like, okay, I get there's a big latent load because, I know this is, there's a lot of biomass in here. So, put all these dehumidifiers in there. Were you surprised by just how dynamic these rooms can be?
Oh, the biggest surprise is always when the lights shut off, right?
Mm-hmm.
Everyone always sees that. In your first grow room or two, you're going along, the lights are on, there's all this heat, the air conditioning's cranking, maybe the dehumidifiers are turning on and off. And then what happens? You turn the lights off. And instantly that heat is gone, which means almost instantly the air conditioning turns off. But your plants are your children, right? Do my kids go to bed right away? Heck no. You gotta go in there and scream at it a couple times. Santa Claus isn't coming if you kids don't shut up and go to sleep. Okay, same thing happens with your plants. Those lights go off, but the plants don't stop transpiring immediately. They don't instantly go to their nighttime mode. They still transpire at a pretty high rate for 10, 15, 20 minutes. So you're going to see a relative humidity spike. And that's kind of like the big shocker that everybody gets. And then even a little bit more on the other end when the lights come on. That's why when we start talking to growers and they start talking about putting their lights in a sunset mode, talk about kicking the dehumidifiers on, forcing them on 10, 15, 20 minutes before lights out, we know we're talking to an experienced grower that knows what they're doing. When we start hearing that from an engineer, we know that he's been called by some upset grower at some point because he or she didn't design it properly, and they've gone through this whole process and figured that out.
Yeah, I mean, growers really struggle. I mean, it seems like it doesn't matter what system, there is going to be a delay, a lag time when the lights turn on and off. Even growers who have a sunset or sunrise period or a ramp on, ramp off. I mean, as soon as that load is gone, it just completely disrupts everything that the system was doing beforehand. And I think on the grower side, one of the things that growers don't always understand is that HVAC equipment doesn't respond as quickly as flipping the switch on lights,
No.
right? I mean, it takes time for, I mean, you have a sensor, it has to register that there was a change and then send a signal to the equipment, and then the equipment has to sense that there was a change and what it needs to do, and then you have to turn on compressors and open valves, and that takes time.
Yeah, and that coil is not going to cool off instantly just because, the dehumidifier, the air conditioner, the chilled water system turns on. It's still, that's those coils, the bigger they are, the larger mass of metal it is. And it's going to take 2, 3, 5, maybe even 10 minutes before it cools down to the point where it's actually starting to remove water.
That's a really good point. The bigger the ship, the harder it is to turn, right?
Exactly. There's that inertia. You gotta get things going. It doesn't want to hop to it right away.
Yeah. One of the things that we're starting to see, especially with the lights turning on, is that the hot gas reheat valve in some of these integrated HVAC systems, right? The hot gas reheat valve was fully open, right? Because we need some dehumidification, but we're preventing that overcooling. So we're doing all this heating. And then all of a sudden you have this sensible load from the lights, and the hot gas reheat is still in the coil.
Yep.
And so
it doesn't go away instantly.
Exactly.
So
now you're double whammy. You have the heat from the lights, and you still have the heat from the hot gas reheat that,
Correct.
And so you see this increase in temperature, and 30 minutes seems to be the time that I see in almost every system for it to recover, overshoot, undershoot, right? And kind of find its balance and then steady out.
That sounds about right.
Yeah.
And so then my question to all of your listeners out here that are growers is 30 minutes of a little bit elevated temperature, is 30 minutes of a little elevated relative humidity, is that really damaging your plants or not? I mean, I don't know the answer. It depends upon the grower and it depends upon the conditions. It can do damage. It depends on how your system's set up.
Yeah. Mark Lefstred, professor out of McGill, I think he tries to sort of calm people down a little bit, that, it not only takes the equipment time to respond, but it also takes the plants time to respond, right? Like they all, like you gave the analogy of kids, putting them to bed, right? It takes them time to actually like settle down and fall asleep. Well, plants, it also takes them time to sort of de-energize or re-energize, right? So as your equipment is responding, your plants are also taking their time to respond. So, I don't know that 30 minutes is necessarily the point at which, they converge to the same point necessarily. But I was going to say is that Mark says, a little bit of variability, 15 minutes here, 30 minutes there, 5 minutes. I mean, it's not, plants used to live outside.
Right. There's a lot of different conditions outside.
Exactly. And they're doing pretty good. Well, they're a little stressed right now in our current environment, but
I think we're still a long ways away from the cities with the dome built over them, so plants are going to have to suffer outside for a little while longer.
If there was one advancement in dehumidification or HVAC technology for this industry, what do you think would make the biggest impact, or what would you like to see?
Sure. I guess the biggest advancement, or maybe the thing that most people are finally looking at, is condensate recovery. So nothing to do with the dehumidification technology, but what's happening with water coming out of this unit. You've got perfectly good water coming out of this unit that with a little bit of filtration, you can reuse again. But too often, I just see that water, going down the drain and away it goes. And then they open the well or they open the faucet to get more water out. That is something I'm going to give kudos to California, their Title 24. They're already starting the code revision cycle for 2025, and condensate recovery and leachate recovery is some of the things that they're looking at. That's also a big thing in New England. A lot of times growers out of Vermont, Connecticut, New York, for whatever plant it is, they're often talking about condensate recovery. Where it surprises me most is when I bring condensate recovery up to somebody from the desert Southwest, they always go, "Oh, that's a great idea." I'm like,
hello,
you're the people who should be thinking about it first. You live in a desert.
Oh, yeah.
Capture that water and reuse it. Filter it, do it again. I mean, that recovery is going to be the biggest advancement that we're going to see over the next couple of years, not so much on the efficiency or the operation.
But I mean, when it comes to agriculture, we should be thinking more about water,
Absolutely.
right? I mean, agriculture worldwide represents 65 to 80% of all of our freshwater use. And the advantage we have by growing indoors in these sealed environments where we're dehumidifying, right? Even if it's brute force dehumidification with refrigeration, we are collecting that water. We have the opportunity to recover, a lot of the water that we're irrigating our plants with. Our plants are only keeping a little, very small fraction of the water we feed them. I was actually just talking to an indoor vertical farm grower client of mine this morning, and they just installed a condensate recovery system. And he said that they have reduced, so before they did condensate recovery, I couldn't even believe these numbers. I made him repeat it like 3 times because I didn't believe him. Before condensate recovery, we're using 10,000 gallons per month of water. Now he
Wow,
said,
okay.
it's actually the plants were using 5 to 6,000 gallons, but he was using RO
Okay.
to treat the water coming in, and it's a 1-to-1 use and waste, this is why I
Yep.
hate fucking RO. Oh, there's my
Oh,
answer.
there we go. You win. Nadia has the first F-bomb.
It took long enough. So the RO system, even though his plants only need 5 to 6,000 gallons, he ended up using 10,000 gallons, and then half of that's going to sewer too. And he said his bill for his sewer is as high as his bill for his water. Okay, so he installed the condensate recovery system. I can't even fathom this number. He said that they consume from the utility two gallons per month, from 10,000 to 2.
Wait, not 2,000, 2 gallons.
I don't
2 jugs
make
of milk.
him repeat it like 3 times because I did not believe him.
I guess I could see that.
That's 99.98% or something like that. I mean, that blows out Dettmers and Kozai's estimations of 98% or something. Like,
That is amazing.
Unfathomable. So I want to ask you a question though, because growers are concerned, right? I feel like there's a curiosity, right? And I think growers see the opportunity, a lot of them do. But the thing that I hear the most from growers is the concern about the quality of the water coming off of the dehumidifier. Yes, algae, yes, maybe some, microbials, blah, blah, blah. But I don't know where this came from, but the idea that there might be heavy metals or something leaching off of the coils and the dehumidifiers.
Sure.
Can you speak to that at all?
Sure. So we've run tests on our own units, on several of our units. And depending upon where in the growth cycle you take the water, it can go anywhere from pretty much as close to distilled water as you can possibly get to something with a few biologicals or other stuff. And a lot of that comes down to change your filter at least before every growth cycle, possibly in between. Take a look at that, because that's going to keep any spores, any plant material that's in the air from getting inside. Because once it gets inside, keep in mind, you've got this environment that's full of water. So mold and other things likes to grow in there. So now filtration first, cleaning the unit second. So that's why all of our new units, I mean, that's one of the emphasis that we created when we started putting together our newest designs that we're coming out with, is stuff that you can get a garden hose up there and just hose the thing out. Take it apart where it's hanging, clean it out. We want to make that as easy as possible to get everything out. Now, is that going to make it perfectly pure water? Our units are made of metal, right? There's aluminum, there's copper, there's steel, and you will get minute amounts of metal coming out of it. Depends upon if it's new or old. We always recommend run them for at least 2 weeks before you recover any water, because there is oils and other things from the manufacturing process that needs to get washed out.
That's a good recommendation.
After that, I don't care whether it's Quest or Carrier or Andon or Train or whoever, there shouldn't be too many heavy metals or anything coming out of there, but there'd be minute amounts. Now, if you start reusing and reusing and reusing it without you know, without doing any kind of filtration, that'll tend to build up, cycle up and concentrate. So that's why there should be a recommendation to do some sort of filtration, and possible UV treatment as well to kill any biologicals in the water. Or you may want to do UV treatment of the coils themselves in the unit or the ductwork before and after. Because a lot of times, we've been called in because there was something growing in the grow facility and it was being blamed on our dehumidifier, but we found out it was actually in the ductwork before or after. Right? So that's the other thing. When you're doing your cleaning, don't stop at the equipment. Look at the ductwork, look above the ductwork, any place dust can settle, anywhere there might be some moisture, especially the air conditioning ductwork, because it's going to be cold. The dust settles on top. You can condensation. Now you've got water, you've got food, perfect place for stuff to grow. Clean the whole facility.
Yeah, that's really good advice. All right. So last question for you.
What kind of beer am I drinking tonight?
Well, that's later. I'm
okay.
going to ask that question next. Last official question. Let's say that.
Okay.
So what do plants crave from dehumidifiers?
The same thing that you and I crave. Comfort. Right?
Ooh.
That's good. This is when I first started at Quest, one of the most horrific things I saw was a picture of one of our dehumidifiers sitting in a grow room, and it looked so wonderful. It was sitting on a cart, and I looked at the plant and I'm like, oh my gosh, you got to get rid of this picture. And they're like, why? I'm like, there's powdery mildew all over that plant, because they had the discharge of the dehumidifier pointing right at a plant. How do you get powdery mildew to grow? Humid, dry, right? So in the Pacific Northwest, that's daytime, nighttime, daytime, nighttime. In this case, it was the discharge of the dehumidifier drying it out. Dehumidifier turns off, it gets humid. The plants do not like to have super dry, super cold air blowing on them. Get your dehumidifiers, get your air conditioning system, get it up high, blowing up above the space with your circulating fans. So when the air comes down and blows on these plants, it's at your desired temperature, it's at your desired relative humidity, so the plant feels comfortable. Just like, when you're sitting in your office, you don't want super warm air blowing on you. You don't want super cold air blowing on you. You want to feel 70 degrees and 50%. So treat your plants the way you treat yourself. Except for, no moisturizers or anything like that. I mean, as far as the air goes. Give them the comfort they desire, whatever that comfort happens to be.
That's a really good answer. Since you brought it up in terms of like sort of best and worst things that you've seen, what would you say is sort of like if you had a grower that had standalone dehumidifiers, maybe they have a few that they're going to put in a room, and then maybe they have, some split fan coil units or even just a package, air conditioner. But we're really relying on the standalones to do the dehumidifiers. Is there sort of like a best practice and sort of where to locate those equipment relative to each other? You mentioned relative to the plants, but what about relative to each other?
So, I mean, with both the air conditioners and the dehumidifiers, you want redundancy, you want things split up. Whether it's a package unit, you want like maybe 2 package units, so you have redundancy. I was going to say in case something breaks, but things always break, period. I would love to tell you that our units run forever, and we have a few that do, but everything's going to break. So redundancy, multiple units, distributing at different points. And then you got to start asking yourself, one, where do I need to pull the air from? You want to pull it from where there's the highest humidity because you want the best capacity out of your units. You want to discharge that air to some place where it's not going to blow directly on the plants, but it's going to give you the dry air where you need it. So that's typically either way up high, so circulating around the top of the room, or sometimes people put it down low, right? So especially if you're growing things on tables, like tomatoes or something where you want to get rid of in a microclimate underneath that's leading to root rot or some other problems down below. I'll see growers put dehumidifiers down low to put that warm, dry air to dry out the root mass, to dry out the growing medium. It depends upon what issues you've been seeing. And then you want to think about the air circulation in the room, right? You want to get the most mixing possible. So don't have dehumidifiers pointing at circulating fans, pointing at air conditioners where everything's fighting each other. In the ice arena industry, we call it the racetrack design, where NASCAR, turn left, turn left. Everybody's always turning left and going in a big circle. We do the same thing in ice arenas. Set up all the ductwork, set up all the circulating fans, so everything's going in the same direction, so we get a nice mixture going. I've seen much more complex and beautiful designs in grow rooms, but whatever works for you, do it to make sure that the air is properly mixed, so what air gets to the plants makes them comfortable. And you don't have circulating fans just pointing at each other, fighting against each other, because again, you're paying for that electricity. Make that electricity do some work for you.
I love hearing that in ice arenas that you do the racetrack design, because that's what we do with horizontal airflow fans and greenhouses all the time. And we try to implement in indoor farms too, and it works, right? I mean, it works across industries, and it's worked in industries for a long time. So, we don't have to reinvent everything, I don't think.
No, you just have to look to curling clubs for all the answers.
There you go. I want to come curling with you. It looks hard.
I curled tonight at 9:00. How fast
do you really?
Yep.
Oh my God. Oh, please send me a picture, please.
All right.
Okay, so that was the end of the official questions. Now I have just a few rapid fire questions for you. They're just meant to be quick, short. I mean, of course, if you want to expand on anything, you can, but just, quick. All right. Are you ready?
Rapid, quick, and no redos, I assume. Whatever comes out of my mouth comes out of my mouth.
You're in trouble. Exactly.
All right.
All right. Are plants high tech or low tech?
Yeah, I'm going to have to go with high tech.
Yeah.
I'm always amazed at what they can do, how they respond, how they react, how they can thrive or not thrive. Biological systems just confuse me all the time. Yeah. Whether it's the dairy cows I grew up with, the children I'm raising here in my house, or the plants growing in all of our operations. I'm gonna go with their high tech. Yeah, they're a low tech origins that just confuse the heck out of me some days.
Yeah. What has cannabis taught you?
Oh man, cannabis has taught me that it is possible to grow plants in an indoor environment locally, wherever you live, at a sustainable, both economically sustainable and resource sustainable method. I mean, cannabis is paving the way for us, but behind it comes lettuce, tomatoes, all kinds of other plants that we're going to need someday to grow locally, instead of shipping strawberries from South America and to Wisconsin in January. It's great that now we're getting the technology put together to do that right here, so I can have a strawberry in Wisconsin in January without feeling overly guilty.
I like that. What would you tell what piece of advice would you give an engineer who is brand new to this industry?
Oh, latent load matters. I've said it, I don't know how many times. Latent load matters. Follow the moisture, everything else will fall into place.
Follow the moisture. Yes. Oh my God, that might be the title right there. Okay. What advice would you give to a brand new grower?
Oh man. I'm trying to think of it. Okay, right now my daughter's upstairs. I'm trying to think of an answer that I could give that won't make you stick your head down and go, "What did you just say, Dad?" Okay, as being from Wisconsin, I'm a Packer fan, and a couple of years ago when the Packers were doing so well, Aaron Rodgers get up, and what Aaron Rodgers said to all the Packer fans is, "Relax, RELAX, relax, everybody. It's gonna come together." Right? Same thing with your grow operation. Your first crop might not be the best. Your first go around with the HVAC system might not work out the way you want. There's going to be tweaking. There's going to be changes. You might want to look into something we call commissioning in the HVAC world, which means getting an independent engineer or at least somebody with a lot of experience looking over the designs from the beginning, looking at the way the equipment's installed, verifying that it's doing what it's supposed to do, and then looking at it after you've been operating for a growth cycle or two to make sure that it's performing the way you expect it to perform. Otherwise, at that point, you want to go back to the engineer, the manufacturers of the equipment, and say, hey, something's not working out right. Let's sit down and figure it out.
Nice. RELAX.
I did spell that right?
Yeah, I think you did.
Okay.
Yeah, you did. Okay, I don't know if you are a cannabis user or not, but if you were or are, what beer and cheese pairing would you want the most?
What beer and cheese pairing? You're talking to somebody from Wisconsin.
I know. I want to know the answer to this question. What am I going to be having when I visit you in Wisconsin?
Oh my goodness. I mean, it depends on what time of year it is. So like right now, okay, in October, I'm going to grab a Marzen Oktoberfest. Yeah. And with that, I want an old cheddar, like a 10-year-old sharp cheddar that's kind of brittle and falling apart, because that nut brown kind of flavor and the cheddar just pairs beautifully. This time of year, I'm reaching for a stout or a porter because it's cooling off. And I also therefore want a nice mellower cheese, like a Havarti, something with a little mouthfeel that kind of crumbles and breaks down. Summertime, well, I'm going to be outside. So, and it's going to be hot. So I'm going to grab a lawnmower beer. So the beer of Wisconsin is the New Glarus Spotted Cow. It's the ultimate lawnmower beer. And with that, since I'm sitting outside, I can delve into my own personal favorite that nobody in my family or neighborhood likes is Limburger. I mean, the stinkiest cheese known to man, but the flavor is phenomenal. But you can only eat it when you're sitting outside, or otherwise your house smells like basically stinky feet for months. And the word divorce gets thrown around a little bit.
Is your lawnmower beer a Pilsner?
Yeah, no, it's this, what do they call it? A cream ale. So
okay,
basically, but yeah, it's going to be a nice light beer. A little bit more body than your typical, Miller Bud or anything like that, but still nice and light, refreshing, and washes away the flavor of the Limburger pretty quick.
So what I'm getting from this is that I need to visit you during different times of the year.
Yes.
Yeah.
Oh yeah, okay. You got to come up several times. I mean,
yeah.
Our only other option is I set up a refrigerated walk-in cooler and we change the temperature in order to simulate the outdoor environment. But, we can do that too.
Yeah. But simulate it for, no, I was going to say simulate it for the good weather. But I guess if I want to try the stout and was it Havarti combo?
Yeah. Nice soft cheese with a stout.
Then if I come in the summer, you got to simulate the winter for me.
But I will take exception as an avid ice fisherman and curler and aficionado of loving hockey. The winter's a pretty fun time, and I don't even ski or snowshoe. I mean, there's a lot to do out there right now besides shovel.
I'm from Northern California. I'm very soft. I go and I visit the snow. It's just, an hour and a half away, but it's still over there.
Gotcha. For me, it's 3 feet over there.
Yeah, and it's probably more than 3 feet deep, I'm guessing.
Yeah, just getting there.
Well, Dan, that is it. Those are all my questions. Thank you so much for doing this with me. I've been looking forward to interviewing you for a long time. So I've known you. I wanted you to be on a guest for since the beginning. So thank you.
Well, this was fun. This was definitely a pleasure.
Yeah.
This was way better than doing real work for a couple hours.
Good. I'm glad.
All those of you who I've been ignoring all afternoon, sorry. I'll get you
sorry. I turned all my notifications off. Exactly.
Yeah.
Well, I'm sure I will see you at an event soon. So we'll catch up again. But this is a fun way to catch up. So thank you.
Definitely.